Good afternoon, everyone. This is the introductory introduction of CSC530, which is algorithms and data structures. I am looking forward to seeing everyone this year. What I wanted to do is, if you can see over here, we have our kind of overview. Just wanted to kind of give you set the tone for the rest of this 7-week semester as far as what we're going to be covering. So for CSC algorithm data structures, basically we're going to be mastering some core concepts of what is an algorithm, what are the various data structures, when do you use what, why do you use what, and we're going to be doing that via C++. Some of you probably already know C++. Others of you may not have at this point, but we're going to try to go on the assumption that we're going to have a primer for C++ to get you started, to make sure that everyone's on the same footing as we go through weeks 1 through 7. One of the things we are going to be pushing is to analyze efficiency. We're not just going to be writing algorithms, just be writing algorithms. A big part of what you're going to be doing is in your project. And in your project, you'll be writing certain algorithms, and we want those algorithms to be efficient. So implementing in C++, we're expecting to analyze efficient algorithms. And again, obviously, as much as possible, we're going to build on real-world solutions so that what you're looking at that we're applying is a real-world situation that you can see how it's being applied out in the real world. So looking at week 1 through 6, one thing that's not shown here, which kind of falls into the build real solutions, is the fact that there will be a project associated with this course. And the project, even though it says right here that we're doing project work in week 6, we will actually be doing project work weeks 1, 2, 3, 4, 5, and 6. With a kind of a staggered point of view. So for example, the project assignment that we give for week 2 will be based on what we learned in week 1. For week 3, it's going to be based on what we learned in week 2. So you're going to have that opportunity to look at, or understand what we're applying for a given project here in each week based on what we previously covered for everyone. So that's the way that things are going to work for the project. Again, not specifically labeled here, but there will be project work starting, especially in week 2, that and each week after that up to week 6, that is basically building on the concepts that we show here. So in week 1, we have the introduction to the course. We're going to be talking a little bit about recursion, C++ classes and details. We're going to make sure that you have C++ set up and can execute it. And so this is kind of the introductory. So recursion, we'll be talking about a little bit about matrices and model analytics. And this that we're covering here is to support the project work that you're going to be doing the next week in week 2. So this information here will be kind of a carryover. And each week, okay, we will have a quiz, an assignment, and student notes. Here we also show discussion questions. Those discussion questions for those who are online is going to be a requirement. Those discussion questions as far as when those who will be meeting with me face-to-face every week. I might be using these as special assignments or extra credit, or maybe for a discussion item in class that we might partake. But in general, the discussion questions will be for the online students, but not necessarily, or not a requirement for face-to-face students. Okay, so that's week 1. In week 2, we're going to look at lists, stacks, and trees. And one thing I want to say, and I hope that this is true, there are going to be some things in here that I'm going to mention. You say, well, what is that? I mean, what's an ADT? Okay, I mean, what is a set, the map, the standard? Okay, that's the information that we're going to be covering each week, okay, that you will grasp. You will understand all of these concepts in its entirely perfectly, or almost perfectly. by the time of the end of the semester. So the fact that you don't understand what a list or what a vector is or what a stack is or what a queue is now, in week 2, we'll be covering that information in detail step by step. So in week 2, we have lists, stacks, and trees. In week 3, we're going to cover hashing and queues, looking at hashing tables. When do we need to rehash? What hashing does for us? We're going to look at queues and queues in general, priority queues specifically, and heaps. So all these things are basically somewhat related as far as queuing. And so this was what we'll be covering in week 3. In week 4, we'll be looking at sorting and disjoint sets, looking at sorting, equivalence, dynamic equivalence, basic structures. Just kind of slide in here again. These concepts that we're talking about here are basically the footstones, okay, of what we're going to be doing in class. Any program that you're going to write in the future is basically going to have a foundation from the things that are mentioned in the algorithms and data structure course. So just keep that in mind. These are basically the foundation that we're going to be using. So with that, okay, week 5, we're talking about graphs and algorithm design. We're talking about the shortest path algorithm, the network flow algorithm, the minimum spanning tree, greedy algorithms, dynamic programming, and randomized algorithms. So also for week 6, advanced topics, amortized analysis, advanced trees, arrays, and heaps. We will talk about the project work. Again, project is going to be from week 2 on. Okay, you'll have something to base you doing your project. So though it says project work, okay, we will have project work each week. Part of that project will be an oral presentation. Okay, so as we go through your project and you're presenting it, you're going to record it, and that will be a key piece of your project grade. For some of you, we may have the opportunity to present, depending on what it looks like. There's no guarantee, but we're going to be looking at possibly picking out a project or two to be able to present to faculty. As this is part of the computer science department, as far as projecting what you've learned. So don't be surprised, depending on how your work looks today. I kind of come to you and say, hey, can you present to the faculty the information that you learned about algorithms and data structure? And basically look at that as being a presentation that will go beyond the classroom work of CSC530. And so that's in week 6. In week 7, we're going to review, discuss finals. Final project submission is going to be due. Comprehensive review, reports, and or presentations. Again, it's basically you're going to be working on this all week. How will everybody be in an oral presentation? No, everybody will not. You will be required to have the oral presentation as a means of your project because you recorded it. And I will have that in order for evaluation. But we're not going to have you basically present to the whole class, everyone, okay? So that's basically more of an accumulation of everything you've gotten together in week 2 through 6. Excuse me. Weeks 2 through 6, week 7 is kind of the culmination of that information into project-related presentation. Okay. And see the goal here: apply algorithmic thinking and data structures to solve problems efficiently. Our keywords: think, implement, analyze, and succeed. So that's basically what we're covering in CSC 530 algorithms and data structures. I'm looking forward to having each one of you. Some of you have taken classes under me before, and I'm be looking for some excellent work out of all of you. I have high standards for you. I have high standards in that when you leave Carolina University, you will shine. And for order to do that, you're going to need to turn in your assignments. You're going to need to do the quizzes. You're going to need to make sure that your project is the best that it can be. So I'm looking for you. If you have issues, text me, call me. That information is going to be available when we have our first meeting. Yeah, anything that is holding you back, I want you to feel free to contact me. If sometime we have to Zoom on Saturday or Zoom on Sunday, I mean, I'll be available. Not saying that my schedule is always going to align, okay, but I'm just relaying this to say that my office hours are going to be based on your requirement for need and the timing of that. Okay. So here's the overview. Again, just real quick, introductory course, list, stacks, and trees, hashing and queues, sorting and disjoint set, graph and algorithm design, advanced topics and program work, review, discussion, and finals. Okay, that's it for our overview. Any questions, let me know. If not, I will see you in week 1 starting in August 17th, 2026. Everybody have a good one. Bye.